Mr. Anderson here, and in this third video of reviewing quadratic functions, I'm going to be solving quadratic equations three different ways: by factoring, using square roots, and using the quadratic formula. First, I want to think about a quadratic equation. So here I have a quadratic equation. All these are quadratic equations. What I want you to notice is that there is only an x. There's only a single variable in this. A variable x. And I can move everything to one side of the equation, and the other side of the equation could be equal to 0, which is exactly what I want to do for solving by factoring, or later on solving using the quadratic formula. So we say a quadratic equation. We got quadratic expression, quadratic equation, quadratic function, and I want to specify, okay, so here, quadratic equation, right? This is what we are solving when we're using the quadratic formula, and what I'll be solving here. A quadratic function, right? So notice here we got quadratic functions. All right, here's a quadratic function, right? It's an equation for a quadratic function. There's a y and an x in it, and therefore I can graph that on my coordinate plane, all right? But there's a y and an x in these. So these are equations for a quadratic function, all right? Now, the corresponding quadratic equations for these would be if we set y equal to 0. I go, okay, what if that y instead was 0? Okay, then I'd have just an x, right? And I'd have 0 on the other side, and that's what I'm solving down there in this video here. And so think about it. Okay, the y and the x, right? Those are representing coordinates for points. When y equals 0, right? When y equals 0, those are all x-intercepts. They're all x-intercepts. So you think about it, we're not going up or down any, right? We're just going left or right. So, say 0, 3, 0, whoops, I'm going the other way around. 3, 0, negative 5, 0, 8, 0, right? All of those are on the x-axis because we are moving left and right, our x-coordinate, but we're not going up or down any. Okay, so therefore, when I have these quadratic equations, the corresponding quadratic equation for a quadratic function is when y equals 0, and when y equals 0, the x is going to be the x-intercept, right? So one way of solving quadratic equations is to find the x-intercepts. Like here are two x-intercepts, right? And that's why I say, like I said earlier on, x-intercepts, they're the same thing as solutions. And more specifically, they're the same thing as real solutions as opposed to complex solutions. All right, here I have just one real solution, right? The quadratic, it comes down and it touches just at one point, right, and goes back up forever. Right here, I have two solutions. All right, the parabola crosses over at two different spots. All right, those are zeros or x-intercepts or solutions or roots. And there's one more thing that a parabola could do, right? And that's right here. See, our x-intercept is way up here, and my parabola does not even touch it. It does not cross over that x-axis, right? So do we say it doesn't have any solutions? Well, more specifically, now that we are using complex numbers, we say it does have solutions. It just has two complex solutions, all right? So there's three things that can happen when I have a quadratic equation, right? This equation with only x in it, it has an x squared in it, has 0 on the other side of the equation, or I can move everything over to one side of the equation, has 0 over the other side. Three things that can happen, okay? I can have no real solutions like this here, which means it will have two complex solutions, or I could have one real solution, like this right here, or I could have two real solutions, right, where it crosses over the x-axis twice. So I want you to keep that in mind about another way of solving quadratic equations, and that is by what we've already been doing, is graphing and identifying x-intercepts, because the x-intercepts are the same things as real solutions. Okay, so let's get on to this factoring. And like I said, the very first thing that you want to do is to move everything to one side of the equation, have the other side of the equation equal to 0. And here, the very first thing, or the only thing I need to do, is add 24 to each side of the equation. I have x squared equals, whoops, why did I say equals? Minus 11x plus 24 equals 0. I got rid of that minus 24. And I have everything. This is the way that I want to start for solving by factoring or solving by using the quadratic formula. Now I am ready to factor. This is a trinomial where a equals 1. Right? Here's our a value. That's that lead coefficient, the number in front of the x squared. Our b value here is negative 11. Our c value is 24. But specifically, I have an a value of 1. All right, that makes our life easier because I know that our factoring is going to look like this. All right, two sets of parentheses. And in those parentheses are going to be two terms each. So we call it binomial factors. Binomial for two terms in each one of these. The first term in each one of these is just going to be a plain old x. All right, and that's how we're going to get to this x squared right here. The other two numbers here, they need to multiply. They need to multiply to be this positive 24, and they need to add to be this negative 11. Okay, so one handy thing that a lot of people do, they take a look at a factor chart just as a quick reference to see, okay, well, what are all the things that multiply up to be 24? And that would be 1 times 24, 2 times 12, 3 times 8, and 4 times 6. And that's all that your factor chart would tell you. And so I take a look at these pairs of factors here, and these all multiply up to 24. So which one of these is going to add up to be a negative 11? And I take a look at this, and I see the 3 and 8, and I see an 11 out of that. And I say, okay, well, yeah, if both of these were negative, right, then negative 3 times negative 8, that would multiply up to be a positive 24. And it would also add up to be a negative 11. So that's what I'm going to use. I'm going to use negative 3 and a negative 8. Okay, and that satisfies the equation above. Okay, now the factoring is the hard part. The solving is the very easy part. We're going to use the zero product property, which says that 0 times anything is 0, like we always know, right? And the idea behind this is like, okay, if this factor, we have two factors here, right? We have this set of parentheses times this set of parentheses, right? They're right next to each other, so it's multiplication. They're clearly not adding. They're clearly not subtracting. They are multiplied together. So if the number for this set of parentheses here, if x minus 3 was equal to 0, right, then it'd be 0 times whatever that is, and we know 0 times anything is 0. It would make this a true statement. Solutions are what makes the equation a true statement. Okay, and likewise, if this factor over here was 0, it would be 0 times whatever number that is, and it would make this statement true. There are going to be two solutions, and that's where I'm going to get these two solutions from. So just the same way that I just said it, I said, what if this x minus 3 equaled 0? Or what if this x minus 8 equals 0? Well, what does x have to equal in order for x minus 3 to equal 0? Well, I would add 3 to each side of the equation, and I would see that x would have to equal 3 in order for that factor to be 0, right? If this x equaled 3, that'd be 3 minus 3, and that would equal 0. So that would be 0 times whatever that is, and it would make that a true statement. Okay, so there is one of my solutions. And I said, okay, well, what about the second factor? What does it take? What value of x do I need in order for that second factor to be equal to 0? And again, just a simple one-step equation. Add 8 to both sides of the equation. And I see, okay, x needs to be 8, and that looks obvious when I look up at the binomial factor. And if x was 8, that would be 8 minus 8, which would make this 0, right, times whatever that is, and it'd make it a true statement, right? And then you look at this and you start thinking, oh, well, you know, I could have done that in my head. I didn't really need to write this part. Okay, but what I want you to know is that that's how we get to the solutions. What makes these statements true, these equations equal. I want both sides of the equation to be equal to 0, and that is by finding what makes each one of those factors 0. If any factor is equal to 0, I'd be multiplying by 0, and the whole thing would be 0. Okay, so just keep in mind that if you don't recognize, you know, what the solution or the 0 is, set that factor that has x in it equal to 0. Okay, because you will notice, so I can actually just do this in my head, right? So because it's just going to be the opposite of this number, right? Because the opposite of subtraction is addition, so 3 minus 3 is going to give me 0, and same thing here, right? 8 minus 8 is going to give me 0. I can just do that in my head. I don't need to do all of that right there, okay? So there's my two solutions. Let's move on to the next one here, and here right away I see that I have a number bigger than 1 as my lead coefficient, and actually I'm going to change this problem a little bit here. I'm not going to have plus 21. All right, I'm going to have minus 20 here. Okay, I think there's a typo here. Let's make that minus 20. Okay, the very first thing you want to do when you see that lead coefficient is not 1, all right, is see if you can factor out a GCF. And here we can. Let's factor out a GCF because I see that 8, 6, and 20, they're all even numbers. They can all be divided by 2. All right, so I know that I can factor out a 2, and what I'm left with is 4x squared minus 3x minus 10 equals 0. Okay, and now I have a little bit smaller lead coefficient to factor. Right? I'm going to have this 2 out front here when I'm factoring, but this part right here is going to factor to two binomial factors. Okay, and the way I'm going to start off here is this 4 right here. I'm going to think of all the factors that multiply to be 4, and that's 1 times 4 and 2 times 2. All right, and I'm also going to think, okay, what are all the factors that equal 10? All right, and that's 1 times 10 and 2 times 5. All right, when we FOIL, and I'm just going to use here 4x, well, let's do a plus 2 there. No, let's do plus 5, I guess. 4x plus 5 and a 2x, oh no, 1x plus 2. And when we FOIL, right, it's double distribution, right? Multiply, there's the first terms, the outside terms, right? Then I go back and I multiply the 5 with the first term and the second term. There's the IL of FOIL, okay? The only way that I am going to get to this x squared term here is by, or more specifically right here, because this is what I'm factoring right now, is by multiplying those first terms on those two binomial factors. All right, multiplying this right here, the 4x and the x, right? Multiplying that right there. That's going to give me an x squared. Notice the outside terms, that's 4x times 2. That's not going to get me an x squared. Inside, 5 times x, that doesn't get me x squared. And the 5 times 2 certainly doesn't get me an x squared. The only way that I get to the x squared is by multiplying 4x times x. So I know that the number in front of the x, it has to be one of these pairs. Okay, either it's a 4 and a 1 or a 2 and a 2. In the same way, the only way that I get to that minus 10 at the end, this right here, the only way I get to that is by multiplying the last two numbers, right? Multiplying these last two numbers on my binomial factors, the 5 and the 2. Right, there's nothing else. When I multiply the first, I get to the x squareds. The O and the I of FOIL, they give me both an x term. All right, so I can, these factors over here that are of 10, I can only use one of those pairs for my second numbers, all right, in my binomial factors, okay? Because I'm really going to use a, what we call a guess and check method to figure out what are the proper numbers that go into each spot here. Okay, so if I'm using only a one of those factors for my last ones, and I'm using only one of these factors over here for my first terms, I know that I have my first term and my last term taken care of, right? And so I'm only concerned about this middle term. I can shift my focus to just this middle term. How do we get that middle term? Well, when we FOIL, when we multiply the 4x times the 2, right? When we multiply, that is the outside terms, the O of FOIL, or when we multiply the two inside terms, all right, the I of FOIL, so the O and the I of FOIL, when we multiply those, each one of those is going to have an x in it, and those will combine to form our middle term here. Okay? So the 4x times the 2, that gives me a positive 8x. Right? And the 5x, 5 times x, that's going to give me a 5x. And I said those combine to give me my middle term. Now this forms up to be 13x. So this is not my solution here. These are actually the numbers that I want to use. I just have a sign issue here, and I'll show you what that is. So it needs to multiply to be a negative 10, right? So one of those second numbers needs to be negative. All right, I can't have them both positive. So let's make this second one a negative 2 rather than a positive 2. That'd be 4x times negative 2 is going to give me a negative 8x. And now notice when I add these two numbers together, negative 8x plus 5x gives me a negative 3x. Okay, which is what I need. That is the middle term. I know that the 5 and the negative 2, all right, that took care of my last term, the negative 10. And I know that the 4x and the x, that took care of my first term. And then the only thing left was the O and the I of FOIL, or you might call it little smiley, right here. I like to call it little smiley right here, and big smiley. When you add those up, all right, that forms your middle term. Okay, and then all your focus is on that. So I know that I have this correct. All right, so all of that explanation there is making sure that I have the right binomial terms. And I'm going to just write it again because I have so much writing on that side. I'm just going to write it again over here. 2 times 4x plus 5 times x minus 2. Okay, and I want to know what makes each one of these factors equal to 0 using my zero product property. All right, notice the 2 doesn't matter. All right, because any value of x is not going to change 2. It's always going to equal just 2. 2 is never going to be 0. It's always going to be 2. All right, but these factors with x in it, I think, okay, well, what value of x would make that 0? I could set it equal to 0. What will make 4x plus 5 equal to 0? And you soon see, oh, that's just a two-step equation. I'd be subtracting 5 and then dividing by 4. 4x equals negative 5, and then divide by 4 on each side to give me x equals negative 5/4. And that is one of my solutions. Okay, the other one we already know. And you think, okay, what makes x minus 2 equal to 0? Oh, that's right. That was just a one-step equation. And that would be if x equaled 2, just taking the opposite. All right, so there's my second solution. That's my two solutions right there. So you really don't have to do all of this either, because if you have this type of a binomial factor, you realize, okay, the 0 for this is, I'm going to take the opposite of that because I'd be subtracting 5 from each side of the equation. And then the next step that I'd be doing is dividing by 4. So I'm going to take the opposite of the 5, negative 5, and then divide by 4, negative 5/4. All right, there's my two solutions. Okay, let's take a look at another one here. 6x cubed plus 21x squared. First thing you always look for is a GCF. And I clearly see a GCF. They can both be divided by 3. All right, so I'm going to factor that out. And they both have at least 2 x's multiplied together. And so I'm going to factor that out. And what I have left after I factor that out is 2x plus 7. Remember, when you are factoring out a GCF, you are dividing out, or you could say you're distributing in reverse. Distributing in reverse, all right? And People sometimes use a factor chart for this. You know, what multiplies up to be 6, 1 times 6, 2 times 3. And what multiplies up to be 21, let's say 1 times 21 or 3 times 7. And you look at those factors there and you're like, okay, what is the biggest number they both have in common? And the answer to that question is 3, right? They both have a 3 in it, and that's why I factored out a 3. They can both be divided by 3. And what do I have left when I divide out that 3? Well, I have a 7 left on the 21 and a 2 left on the 6, because 3 times 2 is 6 and 3 times 7 is 21. All right, so that's how a factor chart can help you out there. As far as the x's, those are easier to spot, I would say. Here we have 3 x's multiplied together, and x times x times x, and here I just have 2 x's. All right, so I can only divide out 2 x's from that. I can't divide out 3 x's from that. I only have 2 that are there, right? So I can only divide out 2. So if I divide out 2 x's from the second term, I'm only left with a 7 there. And if I divide out 2 x's from the first term, I still have 1 x left. All right, and keep in mind you're distributing in reverse. All right, so factoring's the easy part. Factoring's the harder part. Solving's the easier part. And you go for all of your factors that have an x in it. What would make it 0? Well, let's see. If x equaled 0, then x would equal 0, right? That's one of my solutions. And that one actually is one that throws students off a lot. There's no solving to do there. You just set x equal to 0. That'd be, if this was 0, it would be 0 squared, which would be 0, times 3, which is still 0, times whatever this is, which would be 0 still, right? Because if any factor is equal to 0 when you're multiplying, right? Well, that's what factors are, multiplying. Everything's going to be 0, okay? Which is going to make this statement true. Okay, and then the other one, like we had just seen, that would, if we set that factor equal to 0, it's a 2-step equation. I'd be subtracting 7 from each side of the equation first, and then dividing by that coefficient of 2. All right, so that's going to give me a solution, or a 0, of this right here. All right, there's my 2 solutions. Well, one more to go. Let's see. Always factor out a GCF first. And here, just a simple number to factor out, 3. And that leaves me with x squared minus 9. 3 times x squared is 3x squared. 3 times 9 is 27. All right, I still have a difference of squares to factor here. And that's nice and easy. The x plus 3 times x minus 3 equals 0. And I use my 0 product property. All right, for any factors that have x in it. Here, if x equaled negative 3, that would make that factor equal to 0, make the statement true. Here, if x equaled a positive 3, that would make that factor 0 and make the statement true. There's my 2 solutions. All right, really, really simple. Okay, on to solving the following quadratic equations using square roots. Okay, so here, I want you to think of the big picture as just like solving like normal, like you've been doing forever. I'll write that up here. Solving like normal. And when we solve like normal, we're getting x by itself. And we're doing that by eliminating everything that is not x by opposite operations, right? And you do these opposite operations to both sides of the equation, right? Because you can't make the equation unbalanced, right? You can't do one thing to one side of the equation, not the other. So I'm going to draw a line down the middle here and make sure that I do the opposite operation to both sides of the equation. By the way, if you want to work in reverse PEMDAS order, that gets you typically the easiest way to solve equations. Whoops, multiply and divide, yep, add and subtract. If you want to go in reverse PEMDAS order as far as what to get rid of to get x by itself, that's a good technique to use. The first thing that I want to get rid of is any adding or subtracting. So I subtract 3 from both sides of the equation. And what I'm left with is 2x squared equals 50. And so now the next level up, right, is multiply and divide. And so if I want to get rid of that 2 times x squared, right? I don't want to get rid of that exponent yet, right? That's a higher level. I have a multiplication here. So let's get rid of that 2, multiplying by 2 by dividing each side by 2. And that leaves me with x squared equals 50 divided by 2 is 25. Okay, now I get rid of that exponent. All right, so how do I get rid of that exponent of 2? What is the opposite of squaring? And the answer to that is to take the square root. All right, the square root gets rid of that square. That's the opposite. So I will take the square root of each side. Whenever you apply a square root, don't forget you need to take the plus and the minus. Because the square root of 25 is 5, as we all know, and that's the principal square root. But the other root to the square root of 25 is negative 5, because negative 5 and negative 5 is also a positive 25. Okay, so the square root gets rid of square, right? That gets me x all by itself, and the square root of 25 is 5. So I have 2 separate answers here. I've got a positive 5 and a negative 5. You could write it out like this: x equals 5 or x equals negative 5. All right, that plus minus is just shorthand for saying I have those 2 solutions. Okay, on with the second one. All right, using our reverse PEMDAS, I want to get rid of that plus 4 first. All right, so I'm going to add 4 to each side of the equation. Always making sure we're doing opposite operations to the each side of the equation, and doing it to the entire each side of the equation, by the way. All right, so what I have left is 2 times x minus 7 squared equals 32. Okay, now moving up, I got rid of addition and subtraction. Now I want to get rid of multiplication or division. And I have this 2 times the parentheses squared. So I want to get rid of that with division. Divide by 2 on each side. And what I'm left with now is x minus 7 squared equals 16. Okay, now I'm ready, right? I got rid of multiplication, division. The next thing to get rid of is exponent, right? The next level up on PEMDAS is multiplication. You think I cannot break into those parentheses unless I first get rid of that exponent on the outside. So we know to get rid of a square, we will square root each side. And when we apply a square root, don't forget the plus and the minus. All right, because square root gets rid of that square. And notice now that square is gone, there's no reason for the parentheses, right? I just have x minus 7. And we know the square root of 16, right? That's 4. So I have x minus 7 equals plus or minus 4. And, of course, to get rid of the minus 7, we are going to add 7 to each side of the equation. So that gets rid of that minus 7. I've got x all by itself. And I'll put that up here. Okay, so I got x all by itself. And I want to put that 7 in front of the plus minus like this, all right? 7 plus or minus 4. Okay, because we have 2 different answers. That's a positive 4 or a negative 4. That's either 7 plus 4 right? That's one possible solution. X equals 7 plus 4. Or we have the other route where x equals 7 minus 4. Okay, and that's the other possible one. So, or x equals 7 minus 4, and those are two different answers. So, x equals 11, or x equals 7 minus 4 is 3. And that's my two possible solutions there. Okay, one more method in this video, and that is solving by using the quadratic formula. So the quadratic formula, I guess I'll just write it right here in the middle, is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and in this quadratic formula, this b squared minus 4ac, not with the square root, but just that b squared minus 4ac is called the discriminant. That is called the discriminant, and the discriminant can tell us how many of what kind of answers we have. Remember that the different types of answers that we can have two real solutions, right? Crosses the x-axis twice. Or we could have one real solution where our parabola just touches that x-axis in one spot. Or I could have two complex solutions. And that's where our parabola does not touch the x-axis at all. Right? Those are the different possible things. Well, the discriminant, all right, can tell us which one of these we're going to have. I think I got an extra m in there, don't I? Discriminant, yeah, extra n in there, but I think if you look at that square root there, there's plus or minus, right? That gives me two different possibilities. I have this number, negative b, and I'm either adding this square root of that number, or I'm subtracting the square root of that number. Well, if the square root of that number, if b squared minus 4ac, if that is equal to, all right, here, if b squared minus 4ac, if that is equal to 0, all right, you think about it, then this whole thing is going to be 0, the square root of 0. Whether I add 0 or subtract 0, that's not going to change anything, all right, effectively taking away this plus and minus, because if I add 0 or subtract 0, it's the exact same thing. I'm going to end up with the same answer, right? So if the discriminant is 0, I have one real solution. Okay, now what if this discriminant is positive? If this discriminant, b squared minus 4ac, if that is greater than 0, so if it is positive, then I'm going to have a positive square root, and I'm either going to add or subtract that positive square root, and I'll end up with two real solutions. All right? If the b squared minus 4ac is negative, less than 0, all right, then we're going to have two complex solutions, all right, because a negative under a square root, right, you plug that into the calculator, and it's going to give you an error, right? That is where our complex solutions come from, right? A negative under a square root, all right, and we defined I by equaling the square root of -1. All right, so I can take out a negative from a square root and just call it I. All right, that's going to leave me a positive number in the square root, and I won't have a problem taking the square root of a positive number then. All right, so if that b squared minus 4ac is less than 0, then I have a negative under the square root, and that's what causes complex solutions, and we'll see that in question number 15. Okay, so quadratic formula, first thing to do is identify your a, your b, and your c values. That's easy enough. A equals, that's an A, equals 16. B equals -6. Make sure and take it like with the sign in front of it. And C equals -45. Okay, and it's just those three numbers, not any letters or anything like that, no variables. Once I've identified those, I want to plug those into the quadratic formula. All right, so this first step, and don't skip this first step whenever plugging into a formula, and that is to rewrite your formula, and anywhere that you have a letter, put a set of parentheses. So I'm rewriting the quadratic formula, and I am just putting a set of parentheses anywhere that I have a letter, right? So x equals negative parentheses plus or minus square root of parentheses squared minus 4 parentheses parentheses. Okay, all over 2 parentheses. Very good. And then go back and plug in your A, your B, and your C values. All right, this will cut out a whole slew of careless errors. Okay, so these first 2 parentheses, they were B, so I'm going to plug in a -6 in each one of those. And then the next set of parentheses is an A, that's a 16. This in the denominator, that was an A also, I'll put a 16 there. And the only C we have in this is the very last one, that's a -45. Okay. Now, it's time to simplify, and this actually simplifies pretty quickly. I simplify 3 areas on my next simplification. I'll simplify that first area there in front of the plus minus. I'll simplify to find out what the discriminant is, and I'll simplify the denominator. Okay, so on my next step, I'm just plugging these into the calculator. Or, if you can, you figure them out in your head. So -6, that one's pretty easy. That's just a +6. And then plus or minus, let's see what this discriminant is. And it's a pretty large number here. -6 times -6, that's 36. Sometimes I like to just write that above my square root, just so I keep those numbers in mind. And then -4 times 16 minus 45. Okay, well, that's going to be a pretty big number. Just plug all that into my calculator. Let's see, that was 180 times 16, and it's going to be positive. Was it 2,196? I think that's what we end up with. Square root of 2,196. All right, because I think this ends up to be 2160 here. All right, and then the denominator is 32. Okay, and the square root of 2,196 also happens to be 54, so that's convenient. So x equals 6 plus or minus 54, and then divided by 32. Okay, remember that we have 2 separate answers here. Okay, one 6 plus 54 and then divided by 32, and the other one is 6 minus 54 divided by 32. I'll split that up right here and say, so x equals 6 plus 54 divided by 32, which is 60 divided by 32, or I think that was 1.875. Yeah, 1.875. All right, I'll have to edit the video if I'm incorrect there. I don't have a calculator with me right now. All right, so or we have x equals 6 minus 54 divided by 32, and that's going to be negative 48 over 32, and those are both 16, so that's an easier one. Negative 3/2, or we could say negative 1.5, and there's my two solutions. Okay, let's move on to the next one here. Okay, so identify my A, B, and C values. A equals 1, B equals -2, and C equals 10. Rewrite the quadratic formula with parentheses. Okay, so x equals negative parentheses plus or minus the square root of parentheses squared minus 4 parentheses all over 2 parentheses. All right, then go back and plug in your A, B, and C values. All right, your first 2 parentheses, those are B's. Plug in a -2 there and there. The bottom is an A, and the next on top is an A. 1 and 1 there, and the only C is that last one. Plug in a 10 right there. All right, and simplify those 3 areas right up there. Simplify, find out what your discriminant is, and simplify your denominator. And so I have x equals -2 is a +2 plus or minus the square root of, what do we have here? -2 times -2 is 4, minus 4 times 10 is 40. So minus 36 as the discriminant, and all over 2. Now notice we have one of those negative square roots. All right, and we said if b squared minus 4ac is less than 0, we have 2 complex solutions. Right? You plug in the square root of -36 in your calculator, and you will get an error. When you see a square root underneath or a negative underneath a square root, immediately just take that thing out and put it immediately in front of that square root and call it I. All right, because this is, right, square root of -36 is -1 times 36. I'm taking that -1 because the square root of -1 is I, and I'm separating that out, okay? And so this simplifies then. I'll just write it with the I. Equals 2 plus or minus I times the square root of 36, which is 6. All right. Yeah, maybe I'll write that in the next simplification. Okay, and I also want to split this apart into a real portion and an imaginary portion. I'll show you what I'm doing. This is like this right here, 2 over 2, all right, and then plus or minus this part right over here. So I have x equals 2 over 2 plus or minus. When I write I times square root of 36, I'm not going to write I6. All right, that's like bingo. I'm going to write 6i. Just like you wouldn't say x6, you would say 6x. All right, so you can, in a lot of respects, and when we are doing operations with complex numbers, in a lot of respects, you can kind of treat that I as if it was a variable. Not a variable, it is the square root of -1, but there's a lot of things where you see, oh yeah, I just treat it like it was a variable. Okay, and I can simplify these two fractions here. And I want to convince you that 2 over 2 plus or minus 6i over 2 is in fact that top fraction there. Remember, when you add or subtract fractions, right, you need a common denominator, which we have here, which is 2. All right, once you have a common denominator, you add or subtract the numerators. So this would be 2 plus 6i over 2, or 2 minus 6i over 2. In other words, I could say 2 plus or minus 6i, which is that I square root of 36 all over 2. Okay, these are two separate answers. I have 2 over 2, that is 1, and then plus or minus 6i divided by 2. The 6 divided by 2, that's 3, and I. Okay, and there are my two solutions. All right, I have my real part right here, and I have my complex, or my imaginary part, rather, my